Hey y'all, welcome to Art Lab at Home, where we do the science and art experiments that we would normally do in the library in the comfort of your own home using things that you hopefully already have. My name is Kady. You can normally find me at the Clarkston Library, but right now I am stuck at home just like everybody else. So today we are doing my very favorite science experiment in the whole wide world. I love this one so much that I do it at least once a year. And every time I announce it, everyone is like, oh, we don't want to do that. We're so bored. We don't like that. And by the end, I have convinced them. So I'm going to see if I convince you guys too. Today, we are talking all about eggs. Ba, 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 ba. Exciting, right? Okay, now I know eggs don't sound like the most exciting thing in the world, but we're going to do two quick experiments. Well, one quick experiment, one that's going to take a little bit more time. And I hope that by the end, I can convince you of how cool the egg is. So the first thing that we're going to do is pick an egg, and we're going to look at it for a little while. The one thing I want us to really look at is the shape of an egg. What shape is this egg? Now, a lot of you are probably saying that it's an oval, right? We've got like kind of a stretched out circle, and that's close. An oval is actually symmetrical on both sides, and it has not only vertical or horizontal symmetry, it also has vertical symmetry, which means that it looks the exact same side to side and top to bottom. This egg isn't quite that because it's a little bit pinched in up at the top, right? So this top is a little bit skinnier than this bottom. And to me, what that shape looks like is something that you probably see all around you when you're like out driving and looking at buildings with your family. It looks like a shape in architecture called an arch. Now, when I was at my library grabbing supplies for all of these cool experiments before we had to go home, I found this book about the Los Angeles Olympics in our Friends of the Library book sale, and I grabbed it. I haven't paid for it yet, but I will when I get back, I promise. And I want you guys to look and see if you see any arches in this picture. You see a lot, right? I can count 4, 5 just from what I'm showing you, and there's a 6th one over on this side. Now, an arch is a really cool shape, and that's kind of the shape of our egg, right? You can see that our egg is also an arch, because an arch is one of the strongest shapes in architecture. It might not look it, but the way that an arch is constructed with this curve up here, it means that you can apply pressure, and the pressure distributes evenly to both sides. So anyway, even if the pressure is up here, it's not pressing down on top, the pressure is getting distributed to the sides. And that makes an arch a really, really strong architectural feature. And it also makes it a really strong shape for something as fragile as an egg to be, right? Because an egg's pretty fragile. We've all broken them. Sometimes when we mean to, sometimes when we drop a carton and it gets like everywhere and it's really gross. But what if I were to tell you that an egg is one of the strongest things out there because of its shape? So what I'm gonna do is I'm gonna take my hand, I'm gonna put my egg, actually I'm left-handed, so we'll do it with my left hand. Put my egg in the palm of my hand. I'm gonna wrap my fingers around it, and applying even pressure, I'm gonna squeeze as hard as I can. And I'm not gonna be able to break this egg. You guys ready? Make sure it's right in the palm, fingers all the way around. And I'm gonna squeeze as hard as I possibly can, and the egg doesn't break. So I want you guys to try this at home. You're gonna get a regular egg, not one that's been hard boiled, any of that kind of stuff. And you're gonna put it right in the center of your hand, wrap your hand all the way around. And the trick with this is that you have to apply even pressure. So you can't press down on one finger a little bit harder, but if you have even pressure, the shape of that arc in the egg is gonna distribute all of your pressure evenly around the shape, and it won't be able to break. Try it one more time. Okay, and just to prove to you guys that this egg has not been cooked or anything, I'm gonna go ahead and break it, and I'll eat it later as a scrambled egg. So same egg, right into my cup. Ooh, I got a little bit on that book. I'm really gonna have to buy it for sure now. Okay, so that is our very first experiment with the egg, is the mighty strong arch-shaped egg. is to see if you can break an egg, or if your hands are a little bit smaller, give it to one of your parents to try. Make sure that you do it over a sink or something that's easy to wipe up, just in case it takes you a couple times practicing to get that even pressure. And we are going to move on to our next experiment, where we take the shell off of an egg, but leave the egg intact. Bum, 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 bum. So this one takes a little bit of time to set up. You'll have to start it one day and then come back in about 3 or 4 days to see the results of your experiment. But what I did is I took 3 eggs and I put them in a glass, and then I covered them in vinegar. And a couple lessons ago, maybe last lesson, we talked about acids and bases, and we decided that vinegar was an acid, right? Well, the eggshell is made up of something called calcium carbonate, and that is a base, and acids can dissolve bases. So after 3 or 4 days in the vinegar, we are left with, I'm gonna pour this out here, an egg that doesn't have the shell. What's left is a semi-permeable membrane that sits right inside of the shell that protects the white and the yolk from the outside and from the shell. And so we've dissolved away all of the shell, and we're left with that membrane and all of the stuff inside. And you can see it's a little bit squishy. It's kind of like a rubber ball. If I hold it up to the light, you should be able to see the yolk kind of hanging out at the bottom here. That like kind of dark spot usually comes down to the bottom. But it's really cool. It's kind of a weird texture if you've never felt anything like it before. It's a lot of fun to play with, and it feels very delicate. So this is just 1 egg though, right? And I said that I did this with 3 eggs. I want to show you what I did. So this is an egg that I left in vinegar for like 5 days. After, it takes about 2 to 3 days for the eggshell to dissolve in the vinegar. And after that, you can move 2 of your eggs into different cups. So I had my egg that was covered in vinegar. I poured it out in a bowl so that I could get the egg out without breaking it. I put 1 egg in water, and I put 1 egg in corn syrup. Now, vinegar, water, and corn syrup all have different densities. The like strength or the strength of the solution of those is all a little bit different. I don't know if you've ever touched corn syrup, but it's like really kind of thick and sticky and gross feeling. Water is water, and vinegar is pretty close to water, but because it has some extra stuff added, it's just a little bit more dense than water. And what you can see if we look at our corn syrup egg is that it got really like shriveled up. This one you can really see that yolk in there. And it's like not as plump, not as full as our vinegar one was. And the reason for that is something called osmosis. So in osmosis, if you have 2 different solutions on either side of a semi-permeable membrane, the particles in the one that is less concentrated are going to go through that semi-permeable membrane out into the one that is more concentrated in an attempt to dilute it and to make an even concentration on both sides. I drew you a picture. So it looks like this. I know my egg kind of looks like an avocado, but like just go with me on this. So inside our egg, we've got some particles in our egg white. And outside of our egg, we have some, like a lot more particles in our corn syrup. It's a much thicker, much more strongly concentrated solution. And what's gonna happen is our particles inside of our egg are gonna go out into the surrounding environment in an attempt to dilute it. And it looks like this. So the particles inside the egg white will leave through the semi-permeable membrane that we're left with after we dissolve the eggshell. And they'll go hang out in the corn syrup so that it tries to dilute it and it tries to get an even concentration. If you look really carefully at the top, I don't think you can see it through video, but you'll see it when you do it for yourself. If you look very carefully at your corn syrup solution after the egg has been there for a few days, you'll see a thin layer of like water up top. And that's coming outside of that semi-permeable membrane and trying to dilute the corn syrup. Now, we had It's a little bit harder to see the difference in our egg and in our vinegar, our water egg and our vinegar egg. Let's see. So this was my water egg, and this was my vinegar egg. And what I can tell you from feeling them is that the water egg feels more full. It feels a little bit like more bouncy, I guess. I know that this one, my vinegar egg, looks bigger, but I think it was just a bigger egg to start with. But you can feel the difference. It's a slighter difference because vinegar and water have a much closer density to each other than cornstarch does to either of them, but it's still a difference that you can tell. And now, ooh, you have performed the magical dissolving eggshell experiment. They're really fun to kind of play around with. You could probably freak out your siblings or your parents or your caregivers with them, but it takes a little bit of patience, and but the results are really worth it, I think. So go ahead and try both the amazingly strong arch egg, where you can't break it using just your hand, and try the dissolving naked egg experiment where we take off the shell and are left with just seeing what goes on the inside of an egg. And I will see you guys next time. Thank you so much for stopping by.